Hey everybody, Greg here. It's Thursday evening, and I just thought I needed to bring a couple of things up. So I wanted to do this before the weekend. The second post of the week is going pretty well, and I just wanted to explain a couple of things. First of all, let's take an example here. Now, let's say that you believe the mean amount of money in everybody's pocket in the building where you work is $18. So that's your null hypothesis, that the mean amount of money in the pocket is $18. And then you take your sample and you get a sample mean of $13. Okay? And you have all your samples and you put your samples in the calculator. It is going to report a p-value and a t-value. Now, when you in all research, the minimum probability of committing a type 1 error is by default set at 0.05. So if your p-value is less than 0.05, you reject the null hypothesis at a risk of committing a type 1 error of less than 0.05. And if your p-value is not 0.05, then you simply state, I fail to reject the null hypothesis. So I see two things going on here. First, if you reject the null hypothesis, you're not accepting the alternative. Accepting the alternative would mean being absolutely sure that the null hypothesis is wrong, and you can't be. So don't say anything like, I'm accepting the alternative, because that's not true. The other thing is, let the statistical test say what it's meant to say. So if your alpha is set at 0.05 and your p-value is 0.04, you state, I reject the null hypothesis in favor of the alternative, because that's a statistically significant result. A significant result is whenever you reject the null hypothesis. But don't use verbiage like it's highly statistically significant, or it's really cool statistically significant, or sort of significant, because that doesn't apply and that's misleading. And if you see that in research, that shouldn't be in there. So you only reject the null hypothesis or you fail to. The qualitative part is expressed by the alpha. The alpha is the chance, the minimum chance that you could be wrong. So you have to keep, there's always the human tendency to want to explain more than is actually true. So I think everybody did a pretty good job on that. Now, the issue of a one or two tail test came up. The reason we only do two tail tests is for the following. All right, so your null hypothesis is that the mean amount of money in people's pockets is $18. And as a researcher, you want to say you don't think that's true. So you get a sample mean of $22. So you reject the null hypothesis that it's 18. But you can't say that it's higher or lower than 18 with the two-tailed test. Now, once you have a two-tailed test completed, you could shift to a one-tailed test. And in a one-tailed test, your null hypothesis would be that the mean amount of money in the people's pocket is $18 or less, and the alternative hypothesis is that the mean amount of money is $18 or more. So a one-tailed test looks at it from that point of view, but then you have to adjust your p-value by dividing it by 2, and it gets complicated. So if in a ground course we would talk about how to set up a one-tailed test. Here we don't. But if your sample mean is much larger than your hypothesized mean and you reject the null hypothesis, then you could go ahead and set up a one-tailed test if you knew how to do it. And it's actually pretty simple to do. So that's the reason why we're only using two-tailed tests. It's either what you think or it's not. And just because the sample's larger, it doesn't matter. It's just not what you think. And, you know, when you get to dissertation time, you may want to set up some one-tailed tests. It's pretty easy to do. Okay, so I just wanted to clear those things up. The other thing is make sure everybody's doing a good job of this. Report a one sample t-test exactly in APA format, and then just make the statement, I reject the null hypothesis or I fail to. And you don't have to do any more than that. Okay, now one thing on the 3 surveys from the 3 studies from earlier in the week. The one that I like the most is the CTE one because, first of all, I don't know if you noticed, but all these people came to this CTE conference. And so it's a self-selected sample of the population of CTE teachers, which means it's a really bad sample. Okay, and so they noted that, which is good. But it's a self-selected sample. Now, the other thing is, if it was a sample, then they could do some inferential statistics. They could say, well, the null hypothesis was this, and then from our sample we rejected it or not. But they didn't do that. There was no inferential statistics in it, which, why would they not have done that if that group of people was indeed a sample, even though the sample was really poor? Okay, so you don't go to upstate Montana, where everybody likes to hunt, and ask them what they think of the Second Amendment, because that's a biased, that's a self-selected sample. People are going to radio in and say, this is what we think. Or it could be for any issue. A self-selected sample, people say, count me, but that's because they already have an opinion. And that's what happened in the CTE thing. They came to the conference because they believed certain things about CTE. Okay, so the other thing is the p-value that you saw in that study didn't have anything to do with inferential statistics. Table 1 described the survey instrument they use. Now, if you develop a survey and you use it in your research, which is what you might do, then your survey itself will go through a process whereby it is checked for reliability and validity with some statistics like a Cronbach alpha. The p-value referred to the actual validity of the survey instrument itself. So that meant it was a good, reliable instrument, but it didn't have anything to do with the results. So these are kind of things that everybody's starting to look for and get pretty good at. So those are just a couple of things. Now we are going to have our Friday night online session. So if you would like to be a part of that, you can. We'll start at 6:30. And it's been a pretty good week. And once you get hypothesis testing down, it'll continue next week and the week after, and except in a different context. And all you have to do is be very precise on it. And use those calculators. You can experiment a lot with them. So I think that's it. We'll be online Friday night, and everybody have a good rest of your week. Thank you. Bye.